First question for our Module 7 test is it asks you to match each interior angle measure. So each interior angle measure. So it means individual angle to the corresponding regular polygon. Okay, so first we need to remember that a regular polygon means that all angles and the sides are congruent. Okay. The theory that they're asking you to remember here is the interior sum theorem that tells us, we wrote it as n minus 2 times 180. Okay. Remember, we had the regular polygons and we drew as many triangles as we could inside the polygon to determine the total number of degrees. And we found that there's a correlation that n being the number of sides, if you subtract 2 from the number of sides, that's the total number of triangles that you can draw within it. And we know that every triangle has a total of 180 degrees. So for the pentagon, which is 5 sides, we're going to do 3 times 180. Which is 540 degrees. Okay. But remember, that's the total sum of all the angles. Okay. Now, because it's a regular polygon, and you can only do this with a regular polygon, to determine the number of each interior angle, or a single interior angle, we divide the total sum by the number of sides, in this case a pentagon. So we're looking at 540 divided by 5, and that gives us 108 degrees each. So for our pentagon would be D. Okay. Pause the video, do the hexagon and the octagon, and then come back and see if you got the correct answer. Okay, so for the hexagon, remember we have 6 sides. So the number of triangles we can make is 4. So 4 times 180, or we already know that the pentagon is 540, so you just have to add an additional 180 degrees because it's one additional triangle, bringing our total to 720. And dividing by 6, the total number of sides, we get, and you guys know my mental math is terrible, so I need my calculator. So I get 120 for each individual angle for the hexagon. The octagon has 8 sides. So 8 minus 2 is 6. And 6 times 180 gives me a total number of degrees for my octagon to be 1080. And then divide that by total number of sides, which is 8. Each individual angle of a regular octagon would be 135 degrees. So that makes it A. Okay. Okay, so question number 2. So we have a 1, 2, 3, 4. We have a 5-sided figure. Okay, so we just determined that a pentagon 5 sides, has a total of 540 degrees. And we want to find the measure of angle C. Well, I've got I have 3 90-degree angles. So the first thing I'm going to do to make my math easier is I'm going to subtract 90 degrees from my total of 540 to determine how many degrees are B and C. Let's check my math here because I do not trust it. So 540 minus 90. See? 450, not 350. I don't know why I wrote 350. Anyway. So the remaining, does anybody see the mistake I made? I only subtracted 90 degrees, but I have 3 90-degree angles. So to determine the total number of degrees between angles B and C, I actually need to subtract 270 degrees because that's 3 90-degree angles. So 90 plus 90 plus 90 gives me 270. So let's try this again. So let's do 540 minus 270. Oh, and I actually get 270. Go figure. Okay. So by taking the total number of degrees of my pentagon, which we figured out in question 1 to be 540, when I subtract the 390 degrees, which is a total of 270, that lets me know that B and C have a sum of 270 degrees left between them. So now I can solve for x. So I'm going to erase some of this over here. Give me some more room. Okay. So angle B, so let me actually, I know for you honor students, I know you understand this already, but for some of my other students who may also watch this video, I think it's important for me to explain and point out that it is the sum of all 5 angles of my pentagon is 540 degrees. Now angles A, E, and D are all 90. So what I did was I added 90, 90, and 90 already and subtracted the 270 degrees from both sides when I add those 390 degrees together, leaving me with 270 degrees, and the only angles I have remaining are angles B and C. So angle B, what's left? I have 6x plus 1, and angle C is 8x minus 11. And now we just have a straightforward algebraic equation. So what I need to do is I need to remember to combine like terms. So if I have negative 11 and positive 1, so that's going to give me minus 10. And then I have 6x and 8x, which is 14x. Okay, so I'm going to add 10 to both sides to get x by itself, giving me 280 degrees. And when I do 280 divided by 14 to solve for x, I get x to be equal to 20. Okay, now here's the thing, we are not done, okay, because the question asks us for the measure of angle C. Okay, what we found was the value of x, which is 20. So I'm going to substitute in my value of x, which is 20. Oops, sorry, it's not equal signs. So I'm going to do 8 times 20, which is 160. And then I'm going to subtract 11, which is 149. Is our correct answer if I did my math correctly. So 8 times 20 is 160, and when I subtract 11, I do get 149. Okay, so the measure of angle C is 149 degrees. Okay. All right, question 3, it looks like 4 as well, are all based on that initial theorem that we learned about the sum of the interior angles of a polygon, where we drew the triangles to determine how many degrees. So here I have it says we have a regular, again, regular means all angles congruent, a regular 12-sided polygon. We want to know the measure of each interior angle and each exterior angle. Okay, so interior angle we have already reviewed. So it's the number of sides minus 2. That tells me the number of triangles I can create. And then I'm going to multiply by 180. So 12 minus 2 obviously is 10. And when I multiply by 180, I get a total of 1800 degrees. Okay? Now that's the total sum, not the measure of each individual angle. So I need to do 1800 divided by my 12 individual sides, or my 12 angles. And when I divide my total sum by 12, I get 150 degrees. Okay, now the exterior angle. All right, now if you remember, when we drew, when we had our polygons, we discussed what the interior angles, we found the interior angles. In this case, we know that the interior angle is 150. The exterior angle, remember, we use by extending the sides to get the exterior angle. And if you remember, when we extend the side, we create a linear pair or 2 supplementary angles. Okay, and supplementary angles that form a line have a total of 180 degrees. So to find the measure of the exterior angle, I just do 180 minus 150, and that gives me a measure of 30 degrees.